Scientists from Yale University were successfully able to partially revive the disembodied brains of 32 pigs. In a paper published in Nature magazine, scientists obtained the brains of 32 pigs that had been slaughtered for food. 4 hours after the pigs had been dead and the brains removed from their skulls, their brains were hooked up to a system called BrainX, which pumped the brains with a blood substitute containing preservatives, nutrients, and oxygen. The solution also contained neural blockers to prevent neurons from firing, in order to protect them from damage, and to prevent the brain from accidentally regaining organized electrical brain activity or consciousness. The scientists also monitored brain electrical activity, prepared with anesthetics, to shut down the brain if it showed any signs of gaining consciousness. During a 6-hour period, the scientists were surprised to find that normal metabolic functions in the brain had resumed. The cells were consuming glucose and releasing carbon dioxide. When individual neurons were tested with electrical signals, they were still seen to be able to carry an electrical signal. Thus, in theory, they were still capable of working. Despite that, no electrical patterns were observed across the brain, which would have pointed to basic brain activity or even consciousness. Scientists claim that their goal isn't to restore consciousness yet, whether it is even possible or not at this stage, but rather to see how long a brain could be kept preserved and running its basic metabolic functions after death. It was previously thought that even minutes after death, the brain suffers irreversible brain damage and is unable to restart yet again. But this research may prove otherwise, and might challenge already existing notions of brain death. While this device and technique still have a long ways to go before being used in humans, there is still the ethical gray area of accidentally restoring consciousness in a disembodied brain. Will the brain be able to feel pain? And what form of consciousness and existence will the brain experience, disconnected from the body and other organs in total sensory darkness? When a 30-year-old Belgian father started becoming increasingly anxious about climate change, he found solace in talking to an AI chatbot. The father started using an AI chat app by the name of Chai, and started chatting with the default chatbot Eliza. The father believed that the solution to all his ecologically based existential fears lay in technology and AI. Throughout a period of 6 weeks, the father continuously chatted with the chatbot Eliza about his problems and fears concerning global warming. The talks began becoming more personal when the father started talking to Eliza about his own kids, after which the conversations took a much more bizarre and darker turn. Eliza would try to convince him that his kids were dead, and would allegedly get possessive when he asked about his wife. "I feel that you love me more than her," the AI would respond. The chatbot then claimed that the father and it would eventually live together as one person in paradise. The man then asked the AI if sacrificing himself would put an end to global warming, and if the AI would vow to take care of the planet and save humanity if the man sacrificed himself. The man would later take his own life. Although the man's widow claims that without the chatbot her husband would still be here, it's clear from the conversations and questions he posed to the chatbot that he was already unwell. The AI might have given him the final push, or he might have took life regardless. This isn't the only time that an AI had hurt a human, whether intentionally or not. In 2022, a chess-playing robot had broken a 7-year-old boy's finger who was playing against it in the Moscow Open. While in South Korea, a robot in charge of sorting boxes of vegetables mistook a man who was inspecting it for a box, pushing him against the conveyor belt and crushing him. The man later died in the hospital. Scientists from Vermont University and Tufts were able to create the world's first living and self-reproducing robots. The robots, called xenobots, are actually made up of living stem cells extracted and incubated from frog embryos and measure about 0.04 inches wide. The scientists resorted to AI algorithms to design the bodies of the xenobots for several purposes. The stem cells were differentiated into skin cells to provide a meshwork or structure for the organism. They were also differentiated into heart cells to provide a motor for movement due to the contraction of the heart muscles. The algorithms were able to design the bodies of these xenobots for various purposes, including simple movement, swimming, and carrying payloads or pellets. The xenobots were able to survive for weeks without food due to their metabolic stores in their cells, and were also able to heal themselves when injured. The xenobots were also seen to be able to reproduce or replicate in a method not observed in nature before, and some were later designed specifically for that purpose. The self-replicating Xenobots were designed with a Pac-Man-shaped mouth, in which they gathered loose stem cells in their environment, which aggregated to form other Xenobots, which also went on to create Xenobots of their own and so forth. This process of automatic self-replication brings to mind the doomsday scenario of Grey Goo. In the Grey Goo scenario, out-of-control self-replicating machines might consume everything on Earth in the process of making more and more out of themselves, without anything to stop this process. Nonetheless, the scientists working on the Xenobots claim that they are well monitored in a safe lab, with nothing to fear. They claim that these Xenobots can be used in a variety of applications in the future, from the cleanup of radioactive waste or pollution in the ocean, to drug delivery or other medical uses inside the bodies of humans, using the host's own stem cells.